Now we're going to look at examples of naming ionic compounds. We need to have a language of chemistry, and we need to know the types of compounds we're working with. So we're going to begin by talking about ionic compound naming. And so in general, ionic compounds possess one or more metal cations combined with one or more non-metal anions. So a metal cation and a non-metal anion. Here's some examples. The sodium ion combines with chloride in a 1-to-1 ratio, and the chemical formula therefore would be sodium chloride, 1 sodium for every chloride. Iron, this is called iron 2. That ion is the cation, it's a metal ion, transition metal, combines with an oxide ion, the nonmetal, to form what we call iron 2 oxide. Again, a 1-to-1 ratio. The charges have the same size or magnitude, even though they're opposite signs, so we get a 1-to-1 ratio. In this case, there are 3 sodiums combining with what's called an azide ion, N3-, and that ratio is represented over here on the right side of this arrow. So it's Na3, meaning 3 sodium ions and 1 azide ion. So 3-to-1 because 3 positive charges perfectly balances 3 negative charges. A few more over here. Here's a potassium ion. Now this one is combining with a polyatomic ion. So the polyatomic ions can also act as anions. So potassium ion with a charge of plus combines with a nitrate ion with a charge of negative, and that combines in a 1-to-1 ratio, which we call potassium nitrate. Here's the transition metal, Nacl 2, positive 2, combining with the sulfate ion, negative 2. Those charges balance, so we get a 1-to-1 ratio in the formula for the product, Nacl 2 sulfate. Now take a look at the ammonium here. Ammonium NH4+. That's one whole group that has a charge of plus, or +1 if you want to call it that. There are 3 of them here, and the reason there's 3 is they each have a positive charge, but this phosphate ion has a -3 charge. Remember, the 4 as a subscript is the number of atoms, so 4 oxygens. The 3 up above is the charge, so we do have to put either positive or negative. So this is -3 or 3 negative. Those 3 negative charges will combine with these 3 positive charges to form a compound. And notice we use parentheses around the NH4. The reason for that is that we're going to have 3 of them. There's 3 here, so we have to have 3 of them over here, but it's 3 ammoniums, 3 NH4 pluses. So we use parentheses and then a subscript 3 and then the PO4. So let's take a look. Let's try the easier type, which is the case where it's not a transition metal, it's a group 1 or a group 2 metal. Name the cation, the metal ion, and then name the anion, changing the ending of the anion to IDE. Examples, NaCl. So there's your chemical formula. This tells us that this compound has a metal and a nonmetal. Let's remind ourselves just real quickly. Sodium is right over here. That's on the metal side. Chloride is way over here on the right side. That's a nonmetal. Nonmetal's over here. Metal's on the other side. NaCl. The cation is sodium, so we call that sodium. You just name the metal ion. It's a sodium, so we call it sodium. Then we name the nonmetal, and we change the ending to IDE. So chlorine becomes chloride, and we just combine the 2. It's 2 separate words. Sodium, chloride. NaCl, sodium, chloride. Okay? Let's take a look at a second one. This one right here is Sr3P2. The cation is strontium, this element right there. Notice that in the writing of the formulas of ionic compounds, you generally put the cation first and then the anion after that. So let's look to see where strontium is. You'll have to have one with you, a periodic table, so that you can work with these. So strontium is not in this first group. Lithium, sodium, potassium, rubidium, cesium, francium. Second group, maybe? Beryllium, magnesium, calcium. There it is, strontium, Sr. That's in the second group, so that's the metal ion. So Sr would be strontium. Now what about this second element here, P2? Let's come over to the next page so we can finish that one up. That's the anion. It's phosphorus, P2, phosphorus. So let's look for that over here. P, there it is, non-metal. So phosphide. Now you might get confused and call it phosphoride, but it's actually phosphide. So we should memorize the endings of this. So nitrogen is nitride, phosphorus is phosphide. So the name of the anion then is phosphide. So our answer would be strontium phosphide. Name the first element, the metal. Name the second element, change the ending to ID, phosphide. Now one thing that you should be aware of here, this is a very common mistake among students who are learning how to name ionic compounds. There's 3 here and there's a 2 there, but we don't actually indicate that there's a 3 and a 2 in the name, and that might seem confusing to you. Why is that the case? Well, the reason is we know that strontium has to be +2 because of its position in the periodic table. It's an alkaline earth metal. It's right there. There's strontium. Remember, +1, +2. So metal ions in this column are generally +2. So we know its charge. Likewise, phosphide, that is a nonmetal, and it only has 1 charge. That's -3. So if we come look for phosphorus over here, -3. Remember, these are -2, -1. Noble gases, we don't worry about their charges. They don't tend to form charges. So the phosphide has a charge of -3. So what happens is, if you think about it, you have 3 strontiums, and each of them is +2. So the charge of those 3 metal ions is +6. Phosphide, there are 2 of those, and each one of those is -3. That gives us a total negative charge of -6. So see how these charges completely balance? Ionic compounds, the positive charges, all of them together, have to balance the negative charges, all of them together. So since these 2 ions can only combine in one way such that these charges are balanced, there's no reason to indicate that there's 3 of them and 2 of them. That just has to be the case. There have to be 3 and 2. So there's no reason to give the name for 3 and 2 in there. We just call it strontium phosphide. Now that's difficult when you're first learning how to do this because you have to go through a very mechanical procedure of proving that to yourself often. Strontium +2, there's 3 of them, that's +6. Phosphide, here it is. There's 2 of them, each one's -3, that's -6. They're balanced, so it's strontium phosphide. Okay, but you'll get better at that as you continue to do it. So you want to do lots of practice. Okay, so our answer there is strontium phosphide. What about this one? This one has a polyatomic ion. So this is not a metal ion, but it's a polyatomic ion that's positively charged. If you recall, the ammonium ion, that's one that you should memorize. There are 10 that you should memorize. That has a charge of +1, and we just put a plus there to indicate it has a charge of +1. There are 2 of them there, right? 2 of those +1s. So what's the total positive charge? If each one's +1 and there's 2 of them? 2 times +1. Now what about this nonmetal? That's oxygen, right? But remember, oxygen has the charge of -2. So we call it oxide. And so the overall charge of the positive is 2 ammoniums, each one's +1, so that's +2. There's 1 oxygen, so 1 of them, and it's -2, so that's -2. They balance their charge. So again, no need to indicate how many ammoniums. We wouldn't say that there's 2 ammoniums when we name this compound. We would just call it ammonium. So the cation is just named just like it were a metal ion. The name of this ion is ammonium. And then you change the ending of the anion to IDE, so oxygen becomes oxide. So overall, we would call this ammonium oxide. Okay? Here's one more. Now this one's a little more complicated, but not much really. The cation is the iron here, and it has a charge of +2. Now how do we know it's +2? The transition metals these elements right here in the center of the periodic table, there are only 2 of them really that only have 1 charge. So zinc is one of them, +2. Silver is the second one, +1. Okay? All of the others have multiple what we call oxidation numbers or oxidation states, and iron's an example of that. Iron can be +2 or +3. We don't know offhand what it is unless we try to figure it out, measure it in some way. So what happens here is we look at the chemical formula, FeO. We do know that oxygen can only be -2 in an ionic compound, with one exception. That's the case of peroxides, but that's a specific exception to that. So we know that the oxygen is oxide, O2 negative. So since there's 1 oxygen and it has a charge of -2, and there's 1 iron, it has to have a charge of +2. That's the only way the charges can balance. This negative charge has to be the same as the positive charge. Opposite signs, but same magnitude. So if this is -2, that's got to be +2. Okay? So if this is +2 with transition metals, we name the element, and then we put in parentheses the Roman numeral for that charge. Okay? Roman numeral, just as a reminder, for 1 is I, for 2 it's 2 I's, for 3 it's 3 I's, for 4 it's IV, and if you want to go a little bit further, for 5 it's V, and for 6 it's VI. So since the iron has a charge of +2, we would call it iron 2 using Roman numeral 2. So name the metal. If it's a transition metal, you use the Roman numeral for the charge. Name the nonmetal, change the ending to IDE. So iron 2 oxide. Okay? One more time. Transition metal, you look to see if it's in here. If it's in here, with the exception of these 2, the Roman numeral system is generally not used for these. We would just call it zinc. We would just call it silver. But for all the others, we're going to indicate what the charge is using Roman numerals. So iron 2 oxide. The way that we figured out it was 2 was from knowing that the oxygen has to be -2, because in an ionic compound, oxygen is going to be oxide, which is in this column, which has to be -2. Okay. Let's take a look at some practice compounds. Okay, I'm going to go through these here. First one, Na2O. Let's be mechanical about this at first, and then we'll try to go a little bit faster as we go through it. Na2O. Okay, so we first have to find out on the table where it is. Well, there's Na right there. First column, +1. If it's not a transition metal, you can just give the name of the element. So sodium. There's the nonmetal. Oxygen. Oxide. Okay? Nothing fancier than that. Just the name of the metal, name of the nonmetal, change it to IDE. Technically, it's the cation, anion, because we could have a positive polyatomic ion, or we could have a negative anion. A negative polyatomic ion. So let's take a look at this one. This is AlCl3. Okay, well, this is an interesting one, and this is one we should know as well. Right there. This column, +3. Okay, so boron, aluminum, +3. Not a transition metal, so we don't use Roman numerals. Just name the element. So Al, aluminum. Nonmetal, chlorine. There it is over there, chloride. Just for naming it, I'm not worrying what the charges are of these ions. I don't need it for that. If I was curious about how this is going to behave chemically and physically, I would want to know the charges. So I would have to come back here and say, okay, well, this is -1, and this is in here, so that's +3. I would need those for some problems, but not for naming in this case. You do need to know the charges of the transition metals when you do these, though, because they can vary. So Fe2O3. As I said, iron could be 2 or 3, so we don't know which one it is here until we figure it out. This is oxide. You could answer that immediately. We've done that right up here, oxide. Doesn't matter how many of them are, it's just oxide. Now we figure out what the charge here is. Each oxide's -2. 3 times -2, that's -6. Okay? That means this has to be +6, right? -6, +6. But there's 2 irons. And if there's 2 irons, that +6 is split evenly between the 2 metals. So each one has to be +3, right? +3 plus 3 is +6 because there's 2 of them. -2, -2, -2, -6. So iron, charge is 3, Roman numerals. Make sure you memorize the Roman numeral system, at least 1 through 6. Next one, Ni3P2. Okay, it's just a matter of looking, seeing where they are. Nickel's right there, transition metal, so it's going to be nickel. And you're going to have Roman numerals with parentheses. Next one is P. P is right there. That's phosphide. Remember, change the ending to IDE. Now you just go back and figure out what the charge is. Each of these is -3, and there's 2 of them. -3, 2 of them is -6. That means this has to be +6, but there are 3 of them. If there are 3 of them and they add up to +6, each one's got to be +2. Okay? In a lot of these naming problems, you really have to be good at taking 6 divided by 2 or 6 divided by 3. You generally don't have to do 24 divided by 7, but 6 divided by 2 or 6 divided by 3 comes up a lot, because a lot of these have charges of either 2 or 3, positive or negative, depending on which ion it is. So now this one, you may not know this one. This one we would look up in a table of the polyatomic ions. There's one in your textbook. This is called chromate, and it has a charge of -2. This is not one I'm making you memorize, but I'm going to give it to you right here. It's chromate, and it's -2. So if chromate's -2, what's the iron got to be? +2. Iron 2. The 2, the charge goes right there. This is not an indication of how many there are, it's just what the charges are. Chromate. And remember, when you're doing the anion, the IDE is for the elements. You're changing the name of the element to IDE. If it's a polyatomic ion that's 8 or ite, you don't have to change the ending to IDE. That would be a different compound. Now this one is a little challenging because it has a polyatomic ion. This is one you do need to memorize. Phosphate. The one in the parentheses, and that's -3, just like a phosphide is -3. How many of them are there? There's 2, right? There's a phosphate, and there's 2 of them. So 2 times -3, -6. So what do these irons have to add up to? +6. There's 3 of them. So if the 3 of them add up to +6, each one's got to be +2. So iron 2, phosphate. Last one, ZnNO32. This is also a polyatomic ion you need to memorize. This is called the nitrate ion. Remember, there are 10 of them that you need to know. -1. How many nitrates are outside the parentheses? Meaning, if you put a 2 there, how many of the nitrates are there? 2. Each one's -1. That gives you -2. What's the zinc got to be? +2. Do we need to know that it's +2 to name the compound? Let's see. Transition metal. Oh, but there's one of our 2 exceptions. Zinc and silver, we don't need to indicate their charges. So notice here, 3, 2, 1. Those are metals, very common metals. Aluminum, zinc, and silver. So we don't need to put the Roman numeral for zinc. Just call it zinc. Nitrate, metal, non-metal. Okay, so there you go. Zinc, nitrate. So there we've named a bunch of them. one more thing to do is to practice. So what you should do is pause this video, get out a piece of paper, pencil, example, make sure you have a periodic table handy, and probably a list of those 10 polyatomic ions that you maybe not have memorized yet. You will need to memorize them soon, but if you haven't yet, just pull them out. Make sure you've got the list of those. Those were given in the lecture. We're going to name these ones here in just a moment. So go ahead and pause right now. Okay, so let's take a look at the first one, Li3N. I'm going to go through these very quickly and just give you the answers. Based on the rules that we've talked about, you should be able to name these. First column, lithium. That's the metal. That's the cation. Lithium. This is nitrogen. It's in this column right here. So we just change it to nitride. Again, no indication that there's 3 of them because we can figure that out. K2S. K is over here. The name of it is potassium. First column. Potassium. S. There's S right there. -2, right? Sulfide. Just change the ending to IDE. Now here's one with a transition metal, so let's be careful with this one. In fact, what you can do is you can say, well, wait a minute, Ti is a transition metal, and it's not zinc or silver. There it is right there, titanium. Not tin, but titanium. But we know it's a transition metal. So I'm going to go ahead and just put parentheses there and fill in the Roman numerals after. Cl4. Well, that we should know by now is chlorine. That's chloride. Titanium chloride. And if you called it titanium chloride, people might be able to know what you meant by that. They would at least know that you're kind of talking about the right stuff. But to be technically correct, we need to know what the charge of that titanium is. There's only one of them. So we have to calculate that. 4 chlorides. Each one's -1. So what does the titanium have to have? What charge? Opposite of -4. +4. So 4 is IV. Okay. The second one, the next one right here, this is one of the exceptions. Here we don't indicate the charge. If you don't have to indicate the charge, that makes it really easy. You just name the element. Silver. And now here's a polyatomic ion. This is one of the 10 you should know. Carbonate. Silver carbonate. Next one, PbCO3. That one's right here. Now I put lead in here because lead's a really important element. It's not technically a transition metal. It's what's called a post-transition metal. It's post meaning after. But it does have more than one state. It can be +2 or +4. So I did want to give you an example of one that's not a transition metal but does behave somewhat like one. It has 2 possible oxidation states. So this one, we figure out what the charge is. I glossed over the fact that the carbonate ion has a charge of -2, but the carbonate ion does have a charge of -2. So if carbonate's -2, what's the lead got to be? +2, right? So lead 2 carbonate. Okay, so there's one metal where we do actually indicate its oxidation state or its charge using the Roman numeral system that does not show up in the transition metal, but it behaves very much like one. Last one here, CuCN2. Okay, well, cyanide, that's cyanide right there. That is one of the 10 that we should know, polyatomic ions. 2 of them, right? And cyanide has a charge of -1. So when you memorize these 10 polyatomic ions, be aware that that's not just what their formulas are, C and cyanide. You also have to know what their charges are, -1. If there are 2 -1s, that's -2 total. If it's -2 on the anion side, it's got to be +2 on the cation side. So copper right there, transition metal. Figured out its charge is +2. So copper 2. Cyanide. Okay, so that's naming ionic compounds, but it's also figuring out charges in many cases, but this is something you want to practice. So what I would recommend, if you'll definitely want to do the ones at the end of the chapter that are in the assigned homework problems, and of course you'll cover it at some point in ALEX. You have all these problems here. There's actually, what, 1, 2, 3, 4, 5, 6, 7 there, and another 6 here. So that's 13. Practice these again, and then try to find other ones out there that are in the textbook, the practice problems in the textbook, and then you should get pretty good at this.